Andrew Rex. As usual, we first come to its statement. Okay, imagine that in an other universe the speed of light is only 100 meter per second. Okay, first point is that we are not going to consider standard value of speed of light, that is 3.0 into 10 raised to the power 8 meter per second, or sometimes 2.998 into 10 raised to the power 8 meter per second. Rather, we are using a particular given speed of light. Okay, that is instead of 3.0 into 10 raised to the power 8 meter per second, it is only 100 meter per second. Okay, part A of the problem is that is a person traveling along an interstate highway at 100 kilometer per hour ages at what fraction of the rate of a person at rest. Okay, one person is at rest while one person is at 120 kilometer per hour. Okay, part second is this traveler passes by a meter stick. Meter stick means a stick whose length is 1 meter. Okay, meter stick means a stick whose length is 1 meter. Okay, so here length is given. Okay, this traveler passes by a meter stick at rest on the highway. How long does the meter stick appear? Okay, now we move to its solution, but before starting our solution in a formal a regular manner, we first go through several slides which have been chosen from different books, and these slides will provide us a foundation regarding understanding of this problem as well as solution of this problem. Okay, first snapshot is regarding Lorentz factor, which is denoted by gamma. Okay, Lorentz factor gamma is equal to 1 over under root 1 minus u square over c square, where u is the speed of one frame of reference relative to another, while c is the speed of light in vacuum. Okay, second snapshot is about length contraction. Okay, length contraction, the length L naught of an object measured by an observer in an inertial frame of reference in which the object is at rest is called its proper length. Observers in frames moving relative to that frame and parallel to that length will measure a shorter length, shorter in the sense of contraction. Okay, for an observer moving with relative speed v, the measured length is L equal to L naught into under root 1 minus beta square. This alternatively becomes equal to L naught over gamma. That this is the expression for length contraction. Okay, length contraction is written within bracket. Okay, so here, dear students, here beta is v over c. Beta is called speed parameter, gamma is called Lorentz factor. Okay, beta speed parameter, gamma Lorentz factor. Now we come towards solution in a formal manner. Okay, using gamma equal to 1 minus u square over c square. Okay, which we have introduced in the first snapshot. Okay, using gamma equal to 1 minus u square over c square, this becomes equal to 1 over 1 minus, in place of u we are using 120 kilometer per hour, while in place of c we are not using standard value of speed of light, which is 3.0 into 10 raised to the power 8 meter per second, or sometimes 2.998 into 10 raised to the power 8 meter per second. Rather, we are using the value of c see speed of light as 100 meter per second, okay, which is assumed to be alternate value of speed of light in the problem, okay. In the next step, we are converting kilometer into simply meter by multiplying 120 with 1000, so it will become 12 with 4 zeros. Moreover, we are going to convert 1 hour into seconds by multiplying 60 by 60, so 1 hour is equal to 3600 second, and 120 kilometer is equal to 12,000 meter. Over, in place of C we have used 100 meter per second. In the next step, it will become 1 over 1 minus 1111.1111 divided by 10,000, okay, because square of 100 will be 10 raised to the power 4 or 10,000, while meter square per second square will be cancelled with meter square per second square, okay. And we also know that Lorentz factor gamma is always a just number, numerical value, it has no units, okay. After simplification, gamma becomes equal to 1 over 1 minus 0.11111, okay. This alternatively becomes equal to 1 over under root 0.8889, okay. This alternatively becomes equal to 1 over 0.94. This alternatively becomes equal to 1.063, okay. So we have finally calculated the value of Lorentz factor gamma, okay. Now this implies that moving person ages 1.063 minus 1.000 multiplied by 100, this becomes equal to 6.3%, okay. Any difficulty? Actually, dear students, we have calculated Lorentz factor gamma, which has become equal to 1.063. In addition to, after finding Lorentz factor, we have to find out this situation, okay. In order to find out this situation, we make our statement in this mode, that this implies that moving person ages 1.063 minus 1.000 multiplied by 100. This 100 is for percentage, okay. This becomes equal to 6.3% slower. Now length contraction, formula of length contraction is L equal to L naught 1 minus beta square under root. We know that 1 minus beta square under root can also be replaced by Lorentz factor gamma, okay. Because Lorentz factor gamma is 1 over 1 minus v square over c square, or 1 minus u square over c square, okay. So we have just written L equal to L naught into 1 minus beta square in its alternate form as L naught over gamma. L naught is given as 1 meter because in this statement the word meter stick has been used, okay. Meter stick meaning that a stick having length 1 meter, okay. So L naught is 1 meter while gamma is 1.063, which we have calculated in our previous part of this problem, and hence after simplification L becomes equal to 0.94 meter. And this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.